All right, we want to go ahead and look at limits of infinity when it pertains to exponential functions, okay? So if we have f of x equals c times a to the x, this is the function we covered in section 1.5. What does it look like and how do we handle those limits as you go to infinity? Okay, so this one is good. Something very similar would be f of x equals our pal e to the x. Okay, these have the same shape, so something to keep in mind as we go forward. So if we have an exponential growth function, a is greater than 1, okay, for this one. This is what my function would look like, okay? And so what we need to do is think about the limits for an exponential growth function. So we'd have our limit as x approaches infinity of our function here, so I'm just going to call it f of x. What happens here? As x goes to infinity, my y values continue to go up and up and up. So what this means is, as x approaches infinity, my y values are going to go to infinity. Okay. Let's go ahead and look at it as we go to negative infinity. As we look to the left, our y values are going to get extremely close to 0 but not touch, but as we go to the left, we're going to approach 0. This part right here, I have one infinity involved with a number. This is telling me there's a form of an asymptote, and since it's our y value, this would be a horizontal asymptote at y equals 0. Something to take note of. Okay. And then we got exponential decay. That's when your a for this equation would be in between 0 and 1. The similar equation would, for the exponential, would be for your e would be f of x equals e to the negative x. Okay, they have the same shape. So if I were to graph the exponential decay, or if I have e to the negative x, it would look like this. And let's talk about that end behavior, or those limits, as x goes to infinity. Let's call this one, we'll just use f of x again. So this time, as you go all the way to the right, as x gets extremely large, my y values approach 0. And then I would go ahead and do the same thing as x approaches negative infinity of f of x. So if I look all the way to the left, my y values are going to continue to go up and get extremely large, so we're going to infinity. Okay. And once again, I have an infinity with a number, so this is a flag to me that there's an asymptote, and this would be a horizontal asymptote again at y equals 0. You guys can see those on your graph. So when you guys are asked to find limits at infinity for exponentials, you have to think about what they look like graphically, either exponential growth or exponential decay, okay? And that will help you determine that limit. If you ever need to, you can always just go ahead and graph it on your calculator too to get an idea.